I'm going to be talking to you about something called lost features of coastal Britain. They're lost for two reasons. One is I will demonstrate to you that we have actually physically lost quite a lot of them. But they're lost for a second reason as well, and it's because of something called shifting baseline. And it's why it's important that I tell this story, because people forget what coastal Britain looked like even just a short time ago. And it's easy to go to the coast and think, oh, it's always been like this, but actually it's changed an awful lot. So this is some pictures from the internet, from satellite imagery, from Google Earth of the Essex terrestrial landscape. It's actually quite similar to any a photo of a British terrestrial landscape. What you'll see is lots of fields, lots of farmland. They're very angular, kind of rectangles and triangles and squares. And I think it'd be fair to say it's basically extremely modified. It's a highly human modified environment. And you could pretty much say that about much of Northern Europe. Here's some less modified landscapes that may be difficult to see, but these are photos of the uplands. And without any further comment on it, basically what you're seeing is lots of land management associated with heather burning on the uplands. So you see lots of long rectangle and oval strips across the uplands if you look at it from up in the satellites. So no matter where we look, even in our most rural areas and our most kind of British countryside areas, we live in a modified landscape. It's green and open. It may be inspiring to you, but it doesn't really look wild. It doesn't really look scary. And that's because wildscapes are actually close to absent in the United Kingdom. In fact, they're close to absent in much of Central Europe, except at the coast, where the sea dominates the land management, and we don't. And that's what I love about the coast, and it's one of the things that I find really inspiring. Because it's actually one of the places where you can go to, and although there's not big charismatic wolves and bears, the mud and the water combined could get you. And I like that about being outdoors. The problem is we don't really know what we've got till it's gone. On the left here you see a map of England. It's only of England, from the 50-year wetland vision from various NGOs. And on the left is what the wetlands used to be like in England 500 years ago, and on the right is what they look like now. And that's not just happening in England. Let's not just have an England bashing session. This is happening across the world. In North America, where they have actually relatively good wetland conservation, they're losing wetlands. China, now with lots of agricultural development, is catching up. But in Europe, somewhere between around 57% of wetlands has been lost. The highest potential estimate of that loss could be as high as 87% loss of all our wetlands since 1700. And there are lots of reasons, but one of the main reasons on the coast is land reclamation. And this is a map of the area south of here, from basically most of Essex. We've got London down here. We've got the University of Essex up here, and we have the Blackwater estuary. And this red dot I want you to look at, you can see this little tiny projection of some coastal salt marsh creeks coming in to the land here. And the coastal grazing marsh comes in about 5 to 7 kilometres at that time in 1865. And if you look at it now, these are the two projections here, and now it's completely covered in farmland. So that coastal pastoral, semi-wild habitat that was there just in 1865 is now all gone to arable in Essex, Suffolk, Norfolk, you name it. And these losses of coastal features are common. It's not just about those coastal marshes and coastal salt marshes and seagrasses that I'm working in Suffolk and the Stour and the Orwell. We've got a 92% loss. Long-term decline. The Stour and Orwell, the value is 97%. The Blackwater in Essex, I think it's 89% losses of our seagrass habitats. And in oysters, in the subtidal coastal native oyster of Europe, where they're still quite strong here in the southern North Sea, but we used to get 1,600 million oysters until the fisheries crashed. It was thought to be inexhaustible. but that turned out not to be the case, and those features too have been lost. And this is something to be concerned about, because estuaries and coasts are important. They have lots of functions. You've already heard, if you were here earlier, from one of my colleagues saying about all the things that seaweeds and algae and the animals in there, they do for us. They provide functions and services to us that we depend on, from food to the air we breathe. So our coast, because of the interface between us and the sea, they do things for us like trap pollutants so that our water on the beaches are clean. They trap sediments and carbon, which help us cope with runaway climate change and provide lots of provisioning, like food. They're the nursery habitats for all the commercial fish species, for example. Please come in and have a seat if you'd like. You're not disturbing. Come in. So maybe we should restore these habitats so that they start to provide those services again. So with the research that I do is try and go out and actually work out exactly how good are the services that people say about these habitats, and can we use that information to justify financial investment to restore them. So some of the work we've done, for example, has found that the sediments in estuaries, more so than the water, are actually really good at removing pollutants. So you know, we all do things in our house and we flush it down the toilet. We're all probably taking all sorts of medication. We put all sorts of chemicals down the sink. What happens to it? Well, it doesn't all get treated in sewage works. It doesn't all get taken out. It goes out. But it doesn't go out as far as you think. It doesn't get all the way out to sea, because those rich sediments in estuaries on the coasts trap those chemicals. Yes, those habitats are polluted, but the rest of the habitats are not polluted because you've got all these trapping of the chemicals in the sediments. And salt marshes and coastal sediments are also really good for trapping carbon. 55 times the carbon locking potential of rainforests. You know, really important. So if we got those habitats back, could they help us mitigate climate change? Well, for salt marshes, maybe. And we found some results in the Essex estuaries that say that they have some of the highest carbon storage potential of salt marshes in northwestern Europe. And what about fish nursery habitats? The coasts and the estuaries are really important, because the things we like to eat and put in our plate, the cod, the sea bass, the plaice, the sole, at the juvenile stage, they live in our coasts and our estuaries and shallow waters. And we need those habitats. Without those nursery habitats, we won't have the adult fish. And so we're doing some work just now at Essex. Howard, one of my students, working with CFAS, working out what features is it of those nursery habitats that makes them very productive, that promotes good recruitment of adult fish so our fishermen can go out and catch them. Here, closer in Suffolk, we're looking at seagrasses and finding actually seagrasses in the Stour and Orwell in particular are beginning to recover on their own. But there's other areas where we've lost our seagrasses and they're not coming back, and we're trying to find out why. In the news, you'll see promises that seagrasses can deliver a response to climate change. But actually, I'm quite sceptical about that, because that data is from overseas. It's from tropical seagrasses. It's from subtidal seagrasses in warm waters. And there's a danger that we see stories that make quick promises and quick fixes for nature that nature just can't deliver. So my research tries to find out and make sure it can deliver before we spend taxpayers' money on it. But most of the work that I do is about the recovery of the European flat oyster, the native oyster that used to be very abundant in the North Sea. Huge aggregations around it, the British coast. And we've lost, again, upwards of 80% of those habitats by area. It was thought to be so abundant, but people loved to eat them. It used to be a poor man's food that you could buy on the streets. And every time that a bed was discovered, people would go out and overexploit them and they would disappear. In fact, very few are protected to this day. Where are they now? Well, Essex turns out to be quite a stronghold, and some areas in Wales, and some areas in the west coast of Scotland, and they can be found in lower numbers in other areas. And we're working in Essex with a thing called the Essex Native Oyster Restoration Initiative to try and work with nature and bring more of them back. And this all happened with someone called Sarah Allison, who's working with Essex Wildlife Trust, who, speaking to oystermen, not to conservation biologists, speaking to oystermen, found out there's a lot more oysters in Essex than people really think there is. So she went out and worked with them and found out that that was true. The oystermen had found that there was actually some of the most intact and most important oyster beds left in Europe in the southern North Sea off the Essex coast. So she went out and collected some data and then worked with the university to submit that to the government, and we have one of our first, in fact remains the first, marine conservation zone for native oysters in Essex, the Blackwater, Crouch, Roach and Colne MCZ. Brilliant, we've got an MCZ. What are we going to do with it? We want you to come and visit it, but it's kind of an estuarine MCZ. It's kind of brown and muddy. You can't go to the coast and go, oh, I can imagine dolphins, and they're there to be fair, but you can't see anything. And so we have to start thinking about what's in this MCZ, where are the oysters in it, and what could we possibly do in the future to help manage it. And so that's where in this case led by Alice Lown. She's now left the group, but she did some work to try and understand the biology of the native oyster in the southern North Sea, to try and predict how it might respond to conservation intervention, and to look about whether or not these promised services, if we bring oysters back, yes, we can fish them, but what else do we get? Do they help create habitats that are good for biodiversity, for example? So we went out in boats with oystermen and with agencies, and we did lots of surveys, an awful lot of surveys, 370 plus, I can't remember what the exact number is, but lots of surveys on the seabed to look for oysters and what species are associated with them. And you get crabs and starfish, some native species, a lot of non-native species now that is found in the southern North Sea. 396 dredges. And we went out and found out where the oysters were, and importantly where they weren't, where someone had told us they were there in the past, but now they've gone. And what we found is the oystermen were onto something. We've got some of the highest observed densities of this species in the southern North Sea. 4 or 5 oysters per metre squared is quite remarkable now. It used to be much higher in the past, but right now that's really quite remarkable. And we found that there was aggregations in some areas, mainly in historical beds, but yeah, some beds are now extinct. And what we wanted to know is could we predict, if we knew how many oysters we've got in a given place, and we know how much they're growing, and we know how much they're reproducing, and we know what their survival is, could we predict how many we would have next year? So that's what we tried to do. Here you can see in this plot here, a plot of the sizes of oysters in all the different years that we studied oysters. And then we took some oysters and we took them and we stuck them to a piece of string. That might sound mad, but if you have an oyster and you mark it and throw it into the sea and hope you might get it back, you're kidding yourself. I've tried. So in order to get them back again, we had to tether them to something. So that gave us oysters we could put on the seabed and we'd get information back from them. How many survived? What was their growth rate like? So we had 3 pieces of information: their size, their growth, and their survival. And this plot here basically just tells you our model predictions, which are in one of the colours, match what we observed the following year. So our model turned out to be really good, thankfully. And we then use that to make predictions and say, if we do nothing to the native oyster in Essex, it will recover, but it will take a very long time, 75 to 100 years. That wasn't good news for oystermen who are currently not allowed to fish it because there's not enough of them. So we need to intervene. We must do something to get it occurring faster. But what we were excited to hear about is we also asked the model, if the population recovers, can you allow fishing of this really exciting but rare and important species? And the answer is yes, you can. But only a little, maybe up to about 2.5% of the population. Now you'll have heard about fishing fish like cod. People take out 20, 30, 40% of the population. But it turns out the oystermen is a regional, heritage, low impact fishery. They only need 1% per year. You take an oyster, and there's millions of them, you only need 1% to make your living. So they were very happy to get this news. And finally, what about other things? Should we just restore wildlife so that we can eat it? Sometimes I say yes, I like oysters. But there are other services that wildlife provides. And what about the biodiversity question? So we've also looked at that, and to just keep the answer short, the answer is oysters are really good for biodiversity. And it turns out the more of them that we recover, the higher densities of oysters that we can get, the steeper this line is, which is more species associated with those oysters. So the more of them we can get, the more other biodiversity that they provide a habitat for. That's good. The problem is there are some non-native shellfish in the estuaries, and they can actually cancel out that effect. So we've got to be careful about how much of our interventions support non-native shellfish. So, to finish, recovery is necessary if we want those services back. Maybe you don't. And that's okay, that's a societal decision. But if we want those services back, we probably have to do some intervention. Restoration is feasible, that's one way to do it, and we've started that in Essex in 2019. But we do need greater focus in restoration science. It concerns scientists when a charity might tell you, give us money to do some conservation. It's going to deliver something. And we go, oh, well, I haven't seen the evidence for that yet. But it's, conservation does need to be ahead of the science because we must be ready, but we also need to do the science to underpin decisions. And finally, I think our results show that low impact and small fisheries can be part of and compatible with nature recovery, but you have to do the science to underpin it. And we've done that science, and it suggests that we can recover the native oyster for us and for biodiversity, but also for the Essex oysterman. Thank you very much.